have a short video of a Rockwell hardness test which will explain the process of Rockwell hardness testing. Now, I do apologize, and the more inquisitive people will realize that the video you've just seen uses a diamond indenter and reported Rockwell hardness C. The HRB, the Rockwell B test would have used a 16th diameter ball and a lower load, but the test method would be exactly the same. We're now going to look at the Brunel hardness test, and the Brunel hardness test calculates hardness by measuring the diameter of a ball indenter with a microscope. Now, the Brunel hardness test is a macro test. It either uses a 5mm or a 10mm ball indenter and a force of 500 or 1000 kilograms for aluminium. So both the load and the indenter impressions are much, much larger. The larger impression and the greater load means that the test is more tolerant of surface imperfections and more of an average value. It's more of a macro test. We have to prepare the surface for Brunel hardness testing. So again, it has to be parallel and ground flat. And we need to grind it to approximately a 200 grit. And the method that we carry out a Brunel hardness test is that we place the sample on the platen, bring the platen up to the ball indenter, and so the ball indenter just touches the surface, and we then apply the indentation load, take the load off, and then measure the diameter of the resultant impression, spherical impression, using a scaled microscope. Traditionally, or older machines, the impression would have been measured using a microscope. Modern machines can calculate from the diameter using electronics to give you a Brunel hardness test. But we measure the diameter. We can either look up the diameter in tables that will convert the diameter to a Brunel hardness, or the machine can calculate the Brunel hardness test, or if we're really crazy, there's a very complicated mathematical formula which will calculate the Brunel hardness number. But from the Brunel hardness test, we are able to obtain a Brunel hardness number. Now, because the Brunel hardness test uses a large bore and a large diameter, it is very much a macro hardness test. So we can use it on castings, on hot rolled plate, on forgings. Now I have a short video on a Brunel hardness test here. Now this is quite an advanced tester, much more advanced than most people will use. So the process is automated, and also the microscope is built into the hardness tester, where older machines would use a separate standalone microscope.
The Brunel hardness test. Using the Brunel method, the hardness of a turbocharger housing is to be measured. First of all, the tester has to make himself familiar with the testing machine. A monitor and the control panel are positioned in the upper part of the machine. These are used to select and program different testing methods. Below the control panel, a microscope lens with a digital camera and an indenter are installed. These two elements are connected to each other and rotate towards the test piece as required. It is also possible to select and exchange the indenter, so different methods of hardness testing can be conducted on the same testing machine. The support table can be adjusted in height, so the test piece can be positioned at the correct distance to the microscope lens and the indenter. After becoming familiar with the machine, let's start the experiment. The principle of the Brinell hardness test is to press a hard spherical indenter with an exactly defined force onto the test piece, then evaluate the surface area of the indentation. The tester selects a suitable spherical indenter and inserts it into the holding device of the testing machine. Next, he puts the turbocharger housing onto the support table, rotates the microscope lens into vertical position and adjusts the correct height of the test piece. After bringing the test piece surface into focus, he selects the exact spot where the hardness test is to be made. By pushing the start button, the hardness test procedure begins. The testing machine rotates the lens back to its resting position and places the spherical indenter carefully on the test piece surface. Gradually and shock-free, the test force rises to its specified value. After maintaining the test force for a certain time, the indenter automatically lifts off again and the microscope lens pans back to its former position. The indentation can now clearly be seen on the monitor. With the control knob, the tester places 4 measuring lines on the edges of the indentation to measure its diameter.
Just to remind you, the Rockwell hardness tester uses a 1/16 of an inch ball, so it's really a micro test used for machine surfaces, for rolled surfaces, for fine surfaces. The Brinell hardness test is a macro test, so used for castings, extrusions, hot rolled plate. Irrespectively, we will have a Rockwell hardness number or a Brinell hardness number. Now, there are innumerable tables published and books of tables published that convert Rockwell hardness and or Brinell hardness to tensile strength. So by using a Rockwell hardness test, we can estimate the tensile strength of the product that we've used. Hence, both either Rockwell or Brinell tests can be used to establish heat treatment, product quality. In production or manufacturing operations, we don't necessarily need to convert to a tensile strength. We can specify upper and lower hardness number limits to control heat treatment or quality. I trust you've enjoyed that. Here is some further reading. Thank you very much. Thank you.